once again. In this video, we will find out the resultant of the different forces, and we also find out the location of that forces along the x-axis. Yes. So for that, we have to resolve such all forces in x and y direction. So first, this 600 Newton, it is in y direction, so we don't need to resolve it. This is a couple 40 Newton meter. This is an inclined force 1 kilonewton. So in this problem we have to consider the unit also, because the unit of these two forces is a Newton, but unit for this force is a kilonewton. So we have to convert this force into Newton. So 1 kilonewton is equal to 1000 Newton. So this way we have to convert it. Similarly, these all dimensions are in mm. This dimension is in mm, this dimension is mm, but the couple is in meter. So we have to convert this meter into mm. So for that, this 40 into 10 raised to 3 Newton mm. Yes, so this way we have to convert all unit in a Newton and mm. Yes. Now we'll resolve this 1000 Newton force in x and in y direction. So we'll resolve this force in horizontal and vertical direction. So we had an angle with the x-axis, that means x component of 1000 Newton is a cos component. Yes, so 1000 cos 30 is the x component, and 1000 sin 30 is a y component. So this way we convert all forces in x and y direction. Yes, so for resultant we have equation resultant is equal to square root of summation fx square plus summation fy square. So for that we require summation fx, forces in x direction. So for forces in x direction, so we start with first quadrant. In first quadrant we had only one force, which is 600 Newton, and it is in vertical direction, and x component of this 600 Newton is a 0, and this couple has a 0 resultant. That's why x component of couple is also 0. So fx, so first x component is 1000 cos 30, and it is in positive x-axis direction. So 1000 cos 30. Next, this is the 800 Newton force, which is in the negative x-axis. So this is the case. So this way we can find out the summation fx, and this value is come up to 66.025. Yes. So similarly we can find out summation fy in y direction. So first quadrant, in first quadrant there is a 600 Newton force, which is in upward direction. So we will consider it as a positive. Next is 1000 sin 30. It is also in upward direction. That's why plus 1000 sin 30. This comes up to the 1100. Okay, so we can find out the resultant. So by above equation we can find out the resultant. Okay, so resultant is equal to summation fx square plus summation fy square. So we will substitute the value 66.025 square plus 1100 square. So by this we can find out the resultant. So by solving this we get a resultant is equal to 1101.98 Newton. So this is the value for the resultant. Similarly, this resultant is a vector, so we have to find out the direction also. So for direction, so we consider this summation fx. Summation fx is a positive, so x component of resultant in towards right direction, and y component of resultant in a vertical direction, upward direction, and resultant is acting in between. So this is the resultant, this is Rx, and this is Ry, and we can find out this theta x. So for that theta x is equal to tan inverse of summation fy by summation fx. So in this case, always remember you have to take a mod when we have to consider only magnitude, because direction is considered in this diagram. That's why we can ignore the sign of the summation fx and summation fy. Yes, so this way we can find out the theta x by substitute the value. So substitute summation fy is equal to 1100, and summation fx is 66.025. So we get theta x is equal to 86.56. By solving this, we get a 86.56. So this way we can find out the angle for resultant and magnitude for this resultant. Yes. So this is half part of our problem is complete. Now we have to find out the position, and to find out the position we have to use the Varignan's theorem. Yes. So Varignan's theorem says that moment due to resultant at any point, we will consider the origin, we will consider the moment at O point, at O is equal to summation of moment due to all forces at same point. We will consider the same point. Yes. So we have to find out the position of resultant along x-axis. So we will choose the point here, which is at x distance from origin, and we'll mark that as a resultant. This is a Ry and Rx, and this is a resultant. So x component of resultant is passing through point O. That's why moment due to Rx is 0. We have to find out moment due to only Ry. So moment due to resultant is Ry. Ry is nothing but Fy. Fy 1100 into x is a moment, and this rotation is like this. So you will rotate in anti-clockwise direction. This will rotate in anti-clockwise direction. That's why this is a positive. Yes. Next is other all forces. So we start with the 600. So 600 Newton force rotation, again rotation is in this direction. That's why 600 into perpendicular distance is this much, which is 150. 150 is the perpendicular distance. Next is this couple is in anti-clockwise directions. That's why it is positive. So positive 440 into 10 raised to 3. I can write this as 40,000. So 40,000. Next, moment due to this x component. Again, due to x component, object will rotate in a anti-clockwise direction. So due to x component, moment is 1000 cos 30 into a distance. So this is a distance, perpendicular distance. So this distance is a 50 mm. Yes, and rotation is in anti-clockwise direction. So that's why we consider it as a positive. Next, due to this sin 30 component or a vertical component, rotation is in clockwise direction. That's why the rotation is a negative. 1000 sin 30 into distance is this much, and this much distance is given here, x distance, which is 50. Okay. And similar to this, we can find out the moment due to this 800 Newton. So for 800 Newton, the rotation of that object is in clockwise direction. So we have to consider it as a negative. Yes, so negative 800 is a magnitude of force into perpendicular distance is this much. So this is a perpendicular distance between the force and the point O. So this distance is a y distance, which is a 60. Yes. So solving this equation, in this equation there is only one unknown, x is the unknown, so we can find out the position, that is the x distance. Yes, so this is the position of that resultant, and we can find out that by just solving this equation. Yes, so by solving this equation, we get x is equal to 91.18 mm. So this way we find out the position of the result, and already we find out the resultant. So resultant is like this, which is 1101.98 Newton, which makes an angle 86.56 degree with x-axis. So this is the resultant, and position is from O it is at 91.18 mm. Yes, so this way we have to find out the resultant as well as position of the result. For more video, you can subscribe for the channel, and you can like for the video.